Okay, so I'm going to talk a bit about collision detection here. We've got a canvas, and the canvas has on it an obstacle. And the obstacle, in this case, is a rectangle that's drawn at 9,6, and it's got width 2 and it's got height 2. And this means at the top of it, the top Y, is at 6, and the bottom Y is at 8, the left X is at 9, and the right X is at 11. Now you can see this quite clearly on the picture. So there you've got a rectangle that's kind of defined fairly straightforwardly in the scene. Now if we bring in another rectangle, and we can move this around, and the idea is you want to work out when they overlap. We can do this if we know the top Y, the left X, the bottom Y and the right X of the new rectangle. As we move it around, we can check some simple facts. First, is the bottom of the first rectangle above the top of the second? That's the situation we're in at the moment. The bottom of this rectangle is at 5. Move it up a bit, go on, 5. So we know that the bottom of this rectangle at 5 is above the top of the other one, so it can't overlap whatever's going on. The next thing we can check is whether the top of the rectangle is below the bottom of the second one. So if the top of it is, say, at 9, wherever it is, they can't overlap. The same is true of the right and the left. So if the right of one rectangle is to the left of the other one, so the right here is at 7, and that's to the left, it's less than 9, which is the left of the static rectangle. And we can do the same with whether the left of the new rectangle is to the right of the first rectangle. So if the left of the rectangle here is, say, 16, even wherever it goes, it can't overlap. And the key to collision detection is testing these 4 criteria and then working out whether they're true for the rectangles that you're actually dealing with.